Hello everyone. Today our group will present on enhancing Pha Yok Dok with super resolution. These are my teammates. Today we will present. So what is Pha Yok Dok? Pha Yok Dok is also known as Thai silk brocade. Is one of Thailand's most luxurious traditional dust line. It's also originated mainly from Lampang province in northern Thailand. It is woven with gold or silver thread, giving like a shimmering rich effect that looks three-dimensional. These fabrics usually show floral design, geometric shape, and mathematical pattern, making them not just clothes, but an expression of Thai cultural identity. For cultural significance, this tradition dates back to Ayodhya period around the 14th century. Back then, it was worn only by royalty and nobility. Later, during Queen's circuit region, it became a global symbol of Thailand's silk revival. Today, it is worn in wedding festival, Buddhist ceremony, and support local artisan and tourism. For modern significance, it's also economically support rural artisan Fuze tourism in Lampang through weaving demonstration. Also, modernly is innovate in fashion like dresses, accessory, and also blending traditional with contemporary design to preserve the craft globalization. For even objective, the purpose of our study event is like celebrate traditional craftsmanship and also showcase like weaving, demonstrate and exhibition, and also encourage you and designer to innovate and also boost tourism and local community income.
All right, so in this part, we have like low quality data set, and our data set consists of low quality image of Pha Yok Dok textile. The photos were intentionally chosen because the fabric has a like metallic sheen and deep texture that are difficult to capture at low resolution. So in the low quality version, we see blurry details and lost red patterns. So this made the data set a good test case for super resolution, since the goal is to like recover those five textile details. All right. So the first method is called bicubic interpolation method. First, bicubic interpolation is like a classical method for resizing images equal by interpolating a pixel using their 16 nearest neighbor. Why it is simple and fast, the results are often blurry and no new details are restored. The second one is called SRCNN. So SRCNN is a super resolution convolutional neural network. That was one of the earliest deep learning method of image super resolution. So it uses a three-layer CNN to learn how to reconstruct images. Compared to bicubic, SRCNN produce sharper edges to clearer output. However, it is shallow and limited, so it struggle to restore verified detail. Right, so the last method is called Swin IR. So Swin IR will stand for Swin Transformer for Image Restoration. So this is a transformer-based approach that process images with shifted window. The advantage is that it captures both local texture and global structure, allowing to restore fine patterns much more efficiently. The downside is that it is heavier computationally and require pre-trained weight. So right now let's compare the methods. The first one is bicubic. So the bicubic is more like a mathematical interpolation. It sometimes create blurry edges and it has like limited detail recovery. The second one is called SLCNN. SLCNN is convolutional network. It has like the better edge preservation and it is moderate enhancement. And the last one is the Swin IR, which is also advanced level super resolution technique. It is a transformer-based architecture. It restores fine details and global structure, and it also achieves a state-of-art result.
So to tackle the challenges of low resolution images, we use three super resolution methods: bicubic interpolation, SLCNN, and Swin IR. So bicubic interpolation is traditional method, like it resizes using surrounding pixels to predict new pixel values. So SLCNN is like convolutional networks, and the Swing SIR is just a transformer-based architecture. So here are the results that we have tested. So before we show, the baseline input image is a low resolution representation of a fabric pattern. So it exhibits like significant pixelation and blur. And this is the first result we tested with bicubic model. As we can see, the bicubic interpolation produces like reasonably smooth image, but introduced visible blurring and it loss of fine details. We can see that the intricate fabric motif and edges are lost. It is fast, but in the technical sense, although it preserves the structure, it fails to maintain high frequency detail like sharp fabric patterns and intricate textures. And it lost the clarity, and it is particularly evident in the areas like the color transition parts. The next part we tried was the Swin IR. So it provides a higher quality among the model tested. It restores the intricate patterns. And fabric textures are more effective than both bicubic or SRCNN. Output is sharper. It has clear lines, and the details are finer than in the fabric design. So in the technical sense, it lowers it allows the photo to preserve and have fine grained details and the high frequency information across the image that result in a superior representation of the complex textures and intricate designs, making it the ideal for the cases where detail retention is crucial. So the next we tested was SRCNN. So in SRCNN, we can clearly see that it is more clear than bicubic because only in the edges it shows super resolve, but the output have clear, very blue taint, so it shows color distortion. So it is indicating that this model have limitation in the texture handling. So in the technical sense, it underperforms in the high texture areas. It is evident that the blue artifacts is the incomplete reconstruction of the image. It highlights a struggle that the Pha Yok Dok have integrate waves and patterns, making it very crucial for the super resolution models. So our analysis is bicubic model is visually produces a smoother image. It blurs the output, and it has a visible loss, but it's still very especially very motive, but it's still okay. The SLCNN, the super revolution convolutional neural network, it has clear it has clarity, it has fabric edges, but it's not effective with complex structure. But it can still structure the restructuring of the image is incomplete, and it has limitations. For the S1IR, it is the highest quality of restoration. It recovers. It have recovering details of textures and fabrics, and the only downside of this is it is very resource demanding. It is computationally more demanding than other two models. So we can conclude that bicubic model is suitable for time. It is faster, but it has low quality upscaling. The SLCNN produces higher quality, but it only for preserving the edges. Only the S1IR is superior in terms of image quality and the preservation of image details and high frequency textures. It is suitable for a test that is demanding and high resolution and detail restoration. So it is very suitable for this Pha Yok Dok image resolution project. So that is our conclusion. For the future works, we consider model optimization. We will implement real-time applications. We will have multi-scale super resolution to integrate models that scale better, and we aim to augment our data, and we plan to compare our data with other models. So that is our super resolution project. Thank you.